Alright, so here we are with section number 5. This is going to be a little weird because this is the first time you've seen this sort of thing. This is called working with sets. It's a basis of math language, and I'll let you read that, but yeah, okay, let's just see how you do. The first slide is all about vocabulary because it's important that you know these words, because the directions are going to ask you to do certain things. The first one is called roster form. Basically, it's taking the items that are in a set and listing them out using commas and braces. Okay, so we use braces if we want to list out the natural numbers less than 5, then we would write out 1, 2, 3, 4. Okay, so that's the first one. It's just kind of a list of things. Set builder notation is a way of describing what is part of the set, what becomes part of the set. So set builder notation is a formal way of writing it. So if we wanted to say we want to deal with the natural numbers, like or even just any number bigger than 4, we would write it like this: x and then a bar, x greater than 4. So that's read x such that x is greater than 4. This is called set builder notation. It's a formal way of writing it. This is a listing, this is a formal way. And then we have different types of sets. We've got the empty set or null set. It's a set that contains nothing, okay? And it looks like this or like this, where we put our braces but we put nothing inside of it. Okay. The universal set is the largest set that we're using. Okay. And I made an example we're using in roster form 1, 2, 3, 4. A subset would be a set that contains some of the items in the universal set. For instance, 1 and 2. Okay. A complement is the set of all elements in the universal set, not in the subset. Okay, so we'll make sense out of that when we get to an example. But you might want to pause it and write a few of these down. That's up to you. They're in the book, so you could use them there as well. I'm going to move on. Okay, so the first thing is asking us to write it in roster form and set builder notation. So here's what it says. N is the set of even natural numbers that are less than or equal to 12. N is the set of even natural numbers. Remember, a natural number is a counting number. So 1, 2, 3, 4, 5. Okay, so we're going to write it in roster form. Okay, so we write N is, write my braces, and then I want to write down all of the even natural numbers that are less than or equal to 12. So I'm going to write down 2, 4, 6, 8, 10, and 12. Okay, so that is the roster set. And then set builder notation is going to look like this. We're going to write our, okay, so N such that N is going to be we write that N is an even natural number. And N has to be less than or equal to 12. Okay. So N such that N is an even natural number less than or equal to 12. Okay, because that's what it says. We're looking for the set of even natural numbers that are less than or equal to 12. Okay, so roster form, a listing, set builder notation, the formal way of writing it. Okay, now we want to write down, we want to solve this. We've been working on this for a little bit now, and we want to go through the process of solving this first. So we're going to subtract 9. And we divide by -4. So we get n, flip the inequality, n is less than -3. So we write it in the set builder, n such that n is less than -3. Okay. So we're still solving it the same way, and now we're just writing our answer in set builder notation. Okay. So that's the process that we're going through with that type of question. There's another one done in your book for you that you can practice on. Okay, finding subsets. All right. So we have 3 things in our universal set. Remember, this is called the universal. All right. And what we want to do is we want to break it down into all of its parts. Okay. And we're going to start, we have 3 things. So the most we can have in a subset is 3. So list the original set. It is always considered a subset. So there's the original. Then we have to consider all of the subsets that have 2 in them, 2 numbers. So we do 3 and 4, we do 3 and 5, and we do 4 and 5. Okay, so all of these make up a subset of this. So we're starting with the largest number. We write down the original set itself. And then we begin to break it up. This time we're going to do it in 2s, so we do 2s. Then we do it in 1s, so we've got 3 is a subset, 4 is a subset, and 5 is a subset. Okay. So we're doing it systematically. We're starting with the entire thing, and then we're breaking it down based on 2 items in the subset. Then we're doing 1 item, and then we're always going to remember to do no items. So that would be the empty set. So therefore there are 8 subsets of 3, 4, 5. They are the empty set, the subset 3, subset 4, subset 5, subset 3, 4, subset 3, 5, subset 4, 5, and the original value, subset 3, 4, 5. Okay? So depending on how many items there are in the original set, you start with the highest number and you begin working your way down, listing out all of the possibilities. Okay, so looking at this one, this is very similar to the one that we did here. I want to let you go ahead and try it. Okay. There is a thing called the complement. Okay, so look at this Venn diagram. U represents everything. So that's this part right here. And A is a set within that. Okay, A is basically a subset. Okay. Well, the complement would be the reverse of this. It would be everything outside of the circle. Okay, and we call that A prime. Okay, A prime. So what we're trying to do is we're trying to find the opposites. Okay, the ones that go against what we're asking for. Okay, so let's look at this example. The universal set U equals the months of the year, and set A equals the months with exactly 31 days. Okay, so the complement would be all of the months that do not have 31 days. Okay. So if the universal set are the months of the year, that's January through December, set A is equal to the months that have exactly 31 days, then the complement would be the months that do not have 31 days. Okay. Hopefully that makes sense, because it's kind of a logical thing. Complement is the opposite of what the set is telling us. Okay. You can look at the chess example in the textbook if you'd like. Okay. Next one is your practice. You get your chance to ask your questions at the end of the Edpuzzle video. Sorry it went a bit long. It takes a little bit of explaining because it's kind of a weird section. All right, see ya.